This is CS1101 Lecture 12.3. We're going to continue our discussion of objects, and we're also going to be discussing inheritance still, as well as getting into more details of the super keyword. So recall we had this person class, which we defined as a superclass to both student and employee. So we had name as the only instance variable, as well as default constructor, a constructor which is going to take in the parameter name and set the name, and have mutator and accessor methods. We also overrode the toString method to display the name stored for the person, as well as overrode the equals method to be able to check and see if two people were the same. Two person objects contained the same name. Then we declared the student class as an extension to the person class. So student inherits the properties, the data and behaviors of person. So we would say that student, the subclass, extends person, the superclass. And then inside of student, we are defining this instance variable ID. We have the student constructor, which is the default constructor, as well as a two-parameter constructor. And then we're calling super, which is going to be a call to the person constructor, as well as calling the person constructor from our parameterized constructor method. More about this coming up in a few slides. And then we also had methods for resetting a student's name and ID and getting the student's ID. So these are the mutator and accessor methods for this student object. And we discussed that person is a superclass for student, or another way to say that, person is a parent to the child class student. So student is going to inherit the data and behaviors of parent, or of the parent, which is person. So when we're designing an inheritance setup in a class, so in the situation where we have student extends person, we're designing an inherited class called student, which inherits from person. We often need to use the constructor for the base class as well as this new class. So we can easily call the student constructor, but what if we need to call the constructor for this person class? We can't call it by name. This won't work. So if we were to attempt to call the constructor for the person object using the name person, this is going to throw an error. Instead, we refer to this superclass by using the keyword super. So when we say super and then open parentheses and give it parameters, what we're doing is we're calling the constructor, which is a part of this superclass. So we're calling the person constructor. So it expects a name to be passed to it as a parameter. So we're calling the person constructor by using the keyword super, and we're passing it a name. So it initializes the name, which is stored in the instance variable, which is part of the person class. And then after we have appropriately constructed our super object, all of the components which we are inheriting from the superclass, we then need to construct or initialize all of the pieces of student which are extensions of person. So the things which we've added. So we have to initialize our student number. So here In this constructor for the type student, we allow them to pass in an initial name as a parameter and an initial student number as a parameter. Then we set the name by using the person constructor and passing initial name to that constructor as a parameter. And we do that using the super keyword. Then we set the student number, which is a part of the person class, to the initial student number. So now that we've got it coded and we have our super keyword being used to call the constructor for the person class correctly, we need to test this inheritance setup. Since we've just finished coding both classes, person and student, neither one has been tested. A lot of times we have the benefit of building or extending a class which has already been developed and tested, but in this situation that is not the case. So we haven't tested either, so therefore we need to test both the person and student class. So first of all, we need to code a client, so write a test client to declare a student object. Then we need to check that all of the added or overridden methods work, so all of the student-specific components work. And then we need to verify the methods which are common to both person and student. So here's a simple program to test the student class and make sure that both it and the person are performing the functions that we need. So we have declared our class and our main. So this is an executable class in Java. So this is an executable program. We're creating a new student object called S1 and using the default constructor to build the object in memory and then store that memory location in our reference variable S1. This is the derived object, right? It's derived from the class person. And then we're going to use the setName method to set the name to War and Peace. So remember, setName is inherited from the class person. So this is a method from the base class that has been inherited to student from person. And then we're going to use the setStudentNumber method, which is a method that we declared in the student class. So this is not inherited from the person class. We set it to 1, 2, 3, 4. And then we are going to print out our student using s1.toString to test if we have correctly overridden the toString method. So there's a toString method built into the person class, and then we have written a new toString method to print out a student specifically. Remember, to override a method, we have to have the same name, same return type, and same parameter list. So when we are coding our student class, we have to have a return type of string, no parameters, and the name specifically has to be S string. Then when we call s1.toString, it will call the overridden student toString method rather than the person toString method. And then the output is going to be name, space, War and Peace, student number, space, 1, 2, 3, 4. For deeper understanding and to look more closely at examples regarding how to code inheritance, reference the files which are stored in the Lecture 12.3 folder on Brightspace. So there's a file called client.java, person.java, and student.java. The client tests and shows how to use the student.java class, and student extends the superclass person. So when we talk about these inheritance structures, we usually refer to them as relationships. Specifically, there are two types of relationships that we wind up talking about a lot. One is referred to as is a relationship. So a student is a person. It's a hierarchical connection where one category, student, can be treated as a specialized version of another, which is person. So student is the specialized version of a person. Rectangle is a specialized version of a shape. So an inheritance hierarchy is a set of classes connected by is-a relationships that can share common code. So we saw that student is a person and undergraduate is a student. So that's an inheritance hierarchy. Similarly, we could have rectangle is a shape, while ellipse also is a shape, and triangle is a shape. And this is represented in a variant of UML, which was a type of structured representation for these hierarchies. But there's also a second relationship that I referred to or alluded to in the previous slide. So there's is a, so student is a person, but there's also a has a relationship. So in a complex object, often you'll have references to other objects of a simpler class. For example, person has a name. So a person is not a name, so it would be incorrect to say person is a name, but person has a name. So when there's a has a relationship, it may or may not be appropriate to use inheritance. It depends on the situation. Typically, I default to no. If the relationship is has a, then I don't typically use inheritance, but there are deviations from that rule. As an example of why you would not inherit in a has a situation, consider that person has a name and name is a string. However, it would not make sense to say that person extends the type string, because a person is not a more specific type of string. That is not accurate. It would make more sense to simply add a name field to the person class with the name field having the type string. Let's consider another example of inheritance to see if everything's making sense. And this time we're going to imagine that we're dealing with a law firm. The following are things common for all employees at this law firm. Each employee is going to have hours, vacation, and benefits. They're going to be required to attend company orientation to learn general rules, and every employee is going to receive a 20-page manual that's the employee handbook. So all of these things are true regardless of any position held at the law firm. But within the law firm, there are specific divisions, and in these divisions, the rules may be different. So every employee has a 20-page manual. However, a lawyer will have an additional 2-page manual, whereas the secretary will have a 1-page manual additional, and the marketer will have a 3-page manual. And the legal secretary is a specific type of secretary, and they will have an additional 1-page manual on top of the additional 1-page manual held by all secretaries and the 20-page manual held by all employees. These additional manuals add rules and also may change some rules from the larger employee manual. So every employee is expected to work 40 hours a week. Employees all make $40,000 per year, with the exception of legal secretaries who make an additional $5,000 per year, so $45,000 total, and marketers who make an additional $10,000 per year, so $50,000 total. All employees have 2 weeks of paid vacation, except for lawyers who receive a total of 3. And then employees submit their time off or form to apply for leave, and they all use the yellow form except for lawyers who use the pink form. Additionally, each employee has these behaviors. Lawyers know how to sue, marketers know how to advertise, secretaries know how to take dictation, and legal secretaries know how to prepare legal documents. So these would be the behaviors associated with each of these classes. Whereas in the previous slide, we discussed the data associated with each of the classes. So now, based on these specifications, let's make a first draft attempt at implementing the employee class. And we will include appropriate accessor and mutator methods to encapsulate each of the instance variables. So here's our employee class. When we call get hours, it returns the value 40 because every employee is expected to work 40 hours per week. Get salary returns $40,000 because all employees make $40,000. If you call get vacation days, it returns 10, which is 2 weeks paid vacation. And if you call get vacation form, it'll return the string yellow to indicate that employees should use the yellow form to request time off. Now let's implement the secretary class based on the previous employee specifications. So secretary will be a subclass of the superclass employee. And we're going to include a method called take dictation, which will be the behavior of the secretary. That's the action that the secretary can take based on the rules that we've set up. It'll accept a string and print the following, where my text is passed as a string. So the output from the take dictation method will be take dictation of text, my text. So when my text is passed in, the take dictation will print taking dictation of text, colon, space, and then whatever the contents of that string which was passed. So here's a first round attempt for coding the secretary class. But notice we didn't use any inheritance, so we had to redo a lot of the work that we've already done. Get hours, now it still returns 40. Get salary, 40,000. Get vacation days, return 10. Get vacation form, return yellow. So the only difference here is this take dictation, where we pass in this text parameter and then print out this string. So we have duplicated this work. We've done redundant code. Hopefully by now, anytime you hear or realize that something is being coded redundantly, you know that's a problem. So there's a big problem because the only unique behavior in the secretary class is that it's capable of taking dictation. The other methods are all part of the employee. Again, as I said, so we have duplicated work, we've made redundant code. This will work, but it's very bad object-oriented programming design. So when I say it's bad object-oriented programming design, what I'm saying is this is the kind of approach to solving a problem that could ultimately lead to you not having a long-term job at a company if this is your approach to code. What would be better? Well, it would be much better to be able to tell Java, hey, I want to use all the contents of the employee class and then just add on take dictation. So to do that, to be able to tell Java, hey, I want to use what we already coded, let's use inheritance to form this new secretary class, basing it on the common employee class. And this is appropriate because employee and secretary have an is-a relationship. So a secretary is an employee. So it makes sense that a secretary class should inherit from the employee class. So by allowing the secretary class to inherit the data and behaviors from the employee class, we can share the code which we've already written into the employee class. So in other words, one class, the one that we are deriving, which is the secretary class, extends the other, absorbing, like I said, data and behavior. So we call the employee class the parent or base or superclass. Again, I usually refer to it as the superclass or base. So we call the employee class the superclass, and we call the secretary class the child derived, or the proper term would be subclass in Java. So the secretary class is a subclass of the superclass, which is employee, and it automatically gets a copy of every field and method from the parent class. So previously we simply wrote in comments, hey, I wish we could take all the behavior of an employee and stick it in the secretary class and then also extend it by adding take dictation. Here, we've actually written that in the correct Java syntax. So we've declared the class, public class. Class is called secretary. And then here's the key, extends keyword employee. So this tells Java secretary is a subclass of the superclass employee. So it inherits employee. Now we can make use of all of the methods and variables which are a part of the employee class, and we can extend it, and we can also override existing methods in the employee class. So here we are adding the take dictation method to the secretary class. So we've inherited all the data and behavior from employee, and now we've also added take dictation. And one cool thing also is that we can actually treat the objects that we instantiate from the secretary class as an employee. After all, a object of type secretary is an employee. We'll talk more about being able to treat an object of type secretary as an employee in a moment. So here's a reminder of what our employee class looks like, right? Get hours, get salary, get vacation days, get vacation form. Hours is 40, salary is 40,000, vacation days is 10, and the vacation form is yellow. Refreshing your memory because we're about to create the lawyer class, which will extend employee. So refresher on the lawyer specifications. Lawyers get an extra week of vacation, so a total of 3 weeks or 15 days. Lawyers don't use the yellow form for vacation leave, they use the pink form. And lawyers have the behavior know how to sue. So we want lawyers to inherit most of their behavior from the employee class, but we also are going to have certain pieces of the employee class replaced by new methods in our lawyer class. So we're going to replace some parts with new behaviors. So this is another perfect situation for inheritance. We don't only have to use inheritance when we want exactly the same behaviors duplicated into a subclass. We can also use inheritance whenever we want similar behaviors with certain modifications. And keep in mind, a lawyer is still an employee. So lawyer still has and is a relationship to employee. So here's what our lawyer class would look like in code. So we have public class lawyer extends employee. So lawyer is going to inherit the superclass behavior and data, the methods and variables from employee. But we're going to have to override some of the behaviors because they're incorrect for lawyers. So a general employee, when you call get vacation form, is going to return yellow. However, for a lawyer, that's incorrect. We want to return pink. So we want to override, which is to replace the get vacation form method in the employee class with our own get vacation form method in the lawyer class. So that when we call some lawyer object dot get vacation form, we don't wind up with the value yellow, we wind up with the value pink. To override a method, you have to have three things satisfied. You have to have the same return type, the exact same method name, and the exact same parameter list. Get vacation form for employees has a string return type. It's called get vacation form in this exact capitalization, and it has no parameters. So this will override get vacation form as declared in the employee class with our new get vacation form for the lawyer class. Don't get confused on overriding and overloading. Overriding replaces a method. Overloading allows you to have multiple methods of the same name. We also need to override the get vacation days because lawyers don't have 2 weeks, they have 3 weeks. So we are going to override get vacation days. And to do that, we have to have the three requirements: same return type, exact same name, and the exact same parameter list. So get vacation days, and for lawyers, that will return 15. Now, here, this is not overriding. It's a new behavior. So we're going to add a method called sue. And sue is going to simply print out the statement, "I'll see you in court." So we have changed some of the behavior of the general employee to suit our lawyer definition, and we have added the functionality to be able to sue. So we've added a behavior, we've added a method called sue, and we have modified the behaviors, modified the methods, get vacation days, and get vacation form. So one more time, overriding is going to create a new version of a method in a subclass to replace the method in the superclass. The overriding method in this subclass must have the same name, same parameter list, and the same return type as the method in the superclass, which is overriding. And there's no other special syntax involved to tell Java, I want to override the method. If you have these three requirements met, Java will override the method. Overloading is going to allow us to create more flexible methods to address more situations. And functionally, it's going to wind up with multiple methods of the same name, but different parameter lists, different parameter sets. So either different types or different number of parameters. Alternatively, we could have the same set of parameters but a different return type. Java would still be able to use the return type to tell the difference between which of the methods we intended to call, and would therefore be able to correctly overload that method. So to be able to overload a method, or to be able to have two methods with the same name or more, we must either have a different number of parameters, a different type involved with the parameters, or a different return type.